The hierarchical clustering is a different approach completely. This is how you visualize a hierarchical cluster, where it starts at the top. At this point, the way to look at this point is that all the 5 observations are in one cluster. Hierarchical clustering starts there. Okay? Then it breaks it into 2 clusters, meaning 1 and 3 are treated as one cluster, and 2, 4, 5 and 6 are treated as one cluster. Then it breaks it further, and then it goes to 1 and 3 as 2 separate clusters, 2 and 5 as another cluster, 4 and 6 as 2 separate clusters. And the last stage, it also splits 2 and 5. So this is the end. This is definite. It is not probabilistic or random. It starts with all elements in one cluster and goes to the extreme level of one element being a cluster. And once you visually look at this chart, then you say, look, for me, I can see only 2 meaningful clusters here. One is the element 1 and 3 seem to be together, and 2, 5, 4, 6 seem to be together. I am happy with this kind of a separation in my population. So you may choose to cut it at that level and decide to keep 2 clusters. Or okay, you may say, look, I am not so keen on that. I would rather have 1, 3 as one cluster, 2, 5 as another cluster, and 4, 6 as the other cluster. That is another option. So once this gives you an option then to decide the membership once you look at the visual representation of how these elements are grouped together. That is, now the hierarchical clustering may build in 2 ways. It may start at the top, that is, put every element in one cluster and slowly split, come down to the extreme where one element is one cluster in itself. Or it may take the opposite route. It may start with each element as one cluster and start putting them together and build the tree upwards. Either way, the results are the same, because there is no randomness. The only input is the distance matrix that it uses, and then it calculates. So this is the approach. Now there are 3 methods in which one may be able to organize, and why 1 has come to 3 and why not 2. No, how does the program choose whether 3 should be put closer to 1 or 2 should be put closer to 2 is like this. Okay, I mentioned these, just hold on for a second. So no assumption on the number of clusters. Being K means you are saying, okay, 5 clusters, so 3 clusters you make. But in hierarchical you don't say, you just ask the program to build the entire thing, and then you can look at it visually and see what is it that you require. May correspond to meaningful taxonomies. That is where it is more powerful. You can start explaining a few things, maybe start giving names to those segments and things like that. There are 2 approaches. Agglomerative, the meaning it starts with all points as individual clusters, so it builds the tree from the bottom up. So every individual is one cluster, and slowly they are put together, and ultimately all make one cluster, and then you can choose. Or divisive, meaning start with 1, that is the entire thing is one cluster, and you start breaking them down into individuals, ultimately to come at. So traditional hierarchical algorithms use a similarity or a distance matrix. The one that I just presented very briefly earlier, that distance matrix is the fundamental input. There is no randomness there. Okay, that distance matrix, typically an Euclidean distance matrix is created, which is the input for the clustering. That matrix alone is used to create a cluster. How does it typically work? So the first thing is you compute the distance matrix. So you have ready. So you got your 100 observations. So you create a 100 by 100 matrix, which is your distance matrix. So it gives you the distance between any 2 points. Once that is done, let each data point be a cluster. So in an agglomerative way, each point is treated as one individual cluster. Then you merge the 2 closest clusters. Look at the minimum distance. There are 100 pairs. There is 100 C2 pairs of data points. You start merging people which are the closest. So go by the minimum distance and put them together. And then you update the distance matrix. So you got a new set of distance matrix. Okay, because now when you have put point number 1 and point number 7, they become one cluster, and let us call it say C1. The C1 will have a new point, meaning let us call that distance what will be the middle of that value, and until only a single cluster remains. So keep on doing that repeatedly. I mean, the program does it. This is how it typically works. So this is what your first distance matrix is. So these are the 4 points, the 5 points, and this is your first distance matrix. And then you see which are the closest, and you then start putting them in an algorithm agglomerative manner. So you put these points together and they start treating them as one cluster. That is step number 1. Once you have these clusters, these points are now together, you want to go to the next step, that is to start merging the clusters. So how do you merge the clusters? Merge two closest clusters and update the distance matrix. So how do you merge two clusters? You have to measure the distance between those two clusters. So there are 3 possible options. Okay, this flows. Let me go past this and then come to this. Distance between two clusters, that is the point where we are stuck. So there are 3 methods. Now when you are at the point level, there is no issue. When you have single individual objects, there is no issue. You know the distance, you just merge. But once you've gone to the next stage where every cluster has at least 2 points, how do you put those clusters into a third or a larger cluster? There are 3 approaches of doing that. One is called the single linkage, the other is called the maximum linkage, or the third one is called the average linkage method. The single linkage method means it is not trying to measure the distance between 2 clusters, not 2 points. Is the minimum distance between any objects in CI and CJ. So suppose in cluster 1 there are 5 points at stage 2. Okay, at stage 1 everyone is one cluster. In stage 2, let's say cluster 1 has 3 points and cluster 2 has 4 points. What is the distance between 1 and 2? Single linkage method says, look, there are 3 points here, there are 2 points here. Compute all the 5 into 2, 10 distances. Whatever is the minimum distance out of these 10 distance is treated as a distance between these 2 clusters. Okay? So likewise you can compute the distance between all the clusters. Single linkage means the minimum distance between any 2 points between 2 clusters. The complete linkage means maximum distance between 2 points of any 2 clusters. And average means average distance. So these are 3 methods. Typically what people will do, you will write all of these and see which is giving you the best discrimination. That is largely governed by the data set. So there is no thumb rule, okay, single is better than complete or complete is better. Average is of course an average, so it will give you some result in between. But to the extent a certain separation is what you are seeking, then you need to go to after the clustering, check how it is, what kind of separation has been achieved. Okay, so single linkage means between 2 clusters find out the least distance. Complete means between 2 clusters, what is the maximum distance among the points is to be taken as the distance between clusters. Single means the least distance between 2 clusters, 2 points of the clusters is to be taken as the distance. Average means the average. Okay. So let's say this is your cluster 1 and it has points 1, 2 and 3. Okay. It is at stage 2. At stage 1 every object is a single cluster. And let us say this is cluster 2 and you have points 4 and 5. And let us say this is cluster 3 and you have points 7 and 6, 7 and 8. Now in the next stage, when I am going to stage 3, I have to choose whether I join C1 and C2 or I join C1 and C3. I have to join. I am building the tree eventually so that everything comes together. Now if I have to choose which is the one should I join, C1 and C2 or C1 and C3 or C2 and C3, I have got 3 choices, right? So if I am taking a single linkage approach, then I will calculate the distance between 1, 4, 1, 5, between 2, 4, 2, 5, between 3, 4 and 3, 5, and out of these 3 into 2, 6 distances, the minimum is, let us say, 0.75. Okay, let's say. That will be taken as a distance between cluster 1 and cluster 2. If I take a maximum approach or a complete link approach, got it? Then suppose the maximum distance among these 6 numbers is 1.8, then the distance between these two clusters will be taken as 1.8. And if I take average linkage approach, then the distance between these two clusters, let's say, is 0.93, then that will be the average linkage. So this, if I take single linkage, I will get the distance between C1, C2 and C1, C3 and C2, C3, and then start merging based on this. There is another distance called Ward's distance. Somewhere it is implemented, so I thought I'll put it here. Again, this cluster is between the, here when we were measuring the clusters, we went back to our distance matrix, which is measures the distance between points, and we use the points to capture the distance between clusters. What distance does slightly different. What it does is it looks at the centroid of Ci and the centroid of Cj and the centroid of Cij. Centroid means the center points. Okay. This between clusters is the difference between total within cluster sum of squares. I will explain this when we implement, and two clusters separately and within cluster sums. So this comes as an output of k means also between clusters and all. So Ward's distance is not a measure of distances, but it is a measure of variance, amount of variance captured within the cluster and between the clusters. It is like your typical ANOVA way of looking at it. Total sum of squares, regression sum of squares, residual sum of squares. Similarly, between cluster sum of squares, within cluster sum of squares, and total sum of squares. That is another way of looking at it. We will talk about it later. I just mentioned, but it's not implemented too frequently. So typically in hierarchical, the thing to do is one has to see where you are getting the maximum discrimination. Okay, so there is no fixed rule which will say that single is going to give you better discrimination than average, or complete is going to give you better discrimination than others. Because it depends on the data that you're dealing with, you will have to examine for yourself how much separation are you getting, especially in the variables that you think are important. Alright, so these are some other diagrams. This is how you should just keep on clicking, this is how it will form. Okay, what we'll do is we'll try and implement a few of these algorithms in R.